Welcome, everyone. Today, we're diving into an explainer on something that's literally changing how we think about the spaces we live, work, and, well, breathe in: biological air hygiene. We're going to look specifically at the P S AMO Disinfection system to break down the science, the hardware, and the real-world applications of this incredible technology. If you've ever wondered how we can make shared indoor environments truly safe at a microscopic level, you are absolutely in the right place.
Okay, let's dive into this. Here's our roadmap for today. We're going to look at the indoor air problem, explore a biological fog solution, check out the nebulizer hardware, take a visual tour of industry applications, and finally, look at the sustainable products powering the whole system.
Now, before we get into the heavy technical details, I want you to think about this. How many invisible contacts do you make when you just step into a crowded room or a busy train? We totally obsess over wiping down the surfaces we touch, right? But get this, a single sneeze can send upwards of 100,000 droplets right into the air we all share. The unseen risks floating around us are completely critical. Room disinfection, it's not just a facility management issue. It's a deeply personal, really urgent matter for all of us.
All right, part one, the indoor air problem. So the fundamental problem here is just human congregation. Whenever people gather in enclosed, limited spaces, the spread of microorganisms is, well, it's inevitable. It happens through direct contact, like someone coughing right next to you, but also through indirect contact, via the shared air we breathe and the surfaces we all touch. The issue is that traditional cleaning methods simply cannot constantly address the air itself or every single surface at exactly the same time. Which brings us to a completely different approach.
Let's move on and see how this builds in part two: a biological fog solution.
So the crucial point is that this AMO system operates on four main pillars for what they call highest room hygiene. First, we want to actually improve the operating environment in closed rooms. Second, biological germ reduction. That means using natural, sustainable agents to neutralize threats, rather than relying on harsh, abrasive chemicals that can be toxic or just ruin surfaces over time. Third, it achieves these hygienic conditions with highly manageable and transparent cost efficiency. And finally, it's a completely validated, proven preventative process.
And here are the actual mechanics of how it works. Traditional wiping always misses spots, right? But this biological fog acts almost like a settling blanket. The really cool part is step two. They can actually adjust the particle size of the fog. Why does that matter? Well, neutralizing a relatively heavy bacteria takes a totally different droplet size than targeting a tiny, lightweight virus. Once it's specifically tuned, this incredibly fine fog actively distributes into every single corner. It actually seeks out germs hiding in those shadow areas that a human cleaner would literally never reach. But, as you might guess, generating a fog this specific requires some serious engineering.
Which brings us to part three: nebulizer hardware and systems.
Now, what's really interesting about this first piece of hardware is its form factor. This is the Mobile Universal Basic Unit. Housed in robust chrome steel, it's a highly mobile cart that can atomize up to 4 liters of biological agent every single hour. And because it's on wheels, facility staff can literally just roll it in for spontaneous disinfection of single rooms up to 300 square meters. It's a fantastic tool for immediate on-demand hygiene right where you need it most.
But, not all situations need a mobile cart. For automatic operation, they've got these really sleek tabletop units and wall-mounted automatic nebulizers. Just imagine a retail space, a restaurant, or maybe an elder care facility. After the daily cleaning crew clocks out, these units can be programmed to just automatically treat the room overnight. It ensures all those hard-to-reach shadow areas and corners are perfectly sanitized before the next day even begins.
And this brilliantly illustrates the true industrial scale of the system. This is a stationary nozzle atomizer. It's designed to be installed directly into the supply air ducts of HVAC systems, basically syncing up right with the building's ventilation controls. Get this, these duct nebulizers can handle massive air volumes, up to 30,000 cubic meters. That's how you treat entire building wings all at once. So where exactly is all this hardware actually being deployed?
Let's find out in Section 4, Applications Across Industries.
Starting off in the hospitality sector, expert system consultants actually work hand-in-hand with hotels to tailor these exact hygiene solutions. Whether they're ensuring pristine air quality in individual guest rooms or keeping up hygiene in massive conference spaces and dining areas, these nebulizer systems just run quietly in the background, protecting guests and staff alike.
Next up, we look at environments with incredibly high turnover and seriously tight spaces: public transportation. Think about airplane cabins, trains, ferries, cruise ships. Like we mentioned earlier, indirect contact in these confined areas is a huge concern. So these automated fogging systems ensure that, between journeys, the air and surfaces are biologically reset.
It drastically reduces transmission risks for the very next wave of passengers.
And for the folks just waiting to board those planes and trains, the system scales up massively. For vast public spaces, think airport terminals or giant train station waiting areas, those heavy-duty HVAC-integrated duct nebulizers we just looked at come into play. They constantly work to optimize hygiene for thousands of people sharing the exact same massive volume of air.
Of course, no air hygiene technology is complete without tackling the most demanding environments on Earth. This BPS technology is absolutely robust enough for strict medical applications. We're talking optimizing hygiene in hospitals, operating rooms, rehab centers, nursing homes. It provides a truly crucial extra layer of defense for highly vulnerable patients and the healthcare workers taking care of them. Wrapping up our tour, we see the system's incredible versatility in some highly specialized facilities. Think humid environments like wellness centers, swimming pools, fitness studios. In these spaces, managing air quality isn't just about germ reduction, it's actually about effective odor reduction too. The biological fog completely thrives in these challenging environments, keeping the atmosphere incredibly fresh and hygienic. Which kind of makes you wonder, what exactly is inside that fog?
Let's break it down in Part 5, Sustainable Hygiene Products.
So BPS produces this surprisingly broad portfolio of biological products built entirely on a sustainable basis. And the applications are just staggeringly diverse. These concentrates, which, by the way, are delivered in volumes anywhere from a single liter all the way up to 1,000 liters, are used for everything from disinfecting food industry production rooms to treating wastewater and cooling systems right down to agricultural stall hygiene. Amazingly, they even produce biological repellents to keep birds away from nesting sites and organic insecticides. I mean, it's a huge umbrella for one core technology.
And the testing data? It shows something pretty remarkable. The quote here says, "Intensively tested and certified, a validated system which shows the highest efficiency." Even external testing institutions and outside consultants were genuinely surprised by how good these results were. The secret to that efficiency is perfect synchronization. The hardware devices and the biological agents are perfectly matched. They're tested together to dial in the exact specific applications and dosages required.
So we've seen how effectively and sustainably this technology can just blanket a room, seeking out hidden germs in everything from a 300 square meter hotel room all the way to a 30,000 cubic meter airport terminal. As we wrap up this explainer, I want to leave you with this thought. As we navigate a world of shared spaces, is this level of biological air hygiene no longer just a nice-to-have luxury, but a fundamental expectation for the air we breathe? Thanks so much for joining me today. Keep asking questions, keep looking at the data, and I'll catch you next time.